Hello guys, I'll be doing the math quiz for this week. So for this question, they ask us when the function is increasing. So basically what we do is the first derivative. So f prime of x is equal to 3x minus 12, 3x squared minus 12. You can do it on the calculator, or you can do it manually. You make it equal to 0, and you find the roots. So x is equal to positive negative 2. You can do SOS or test points. SOS is way faster. So same, opposite, same. So you put negative 2 and then 2, so يعني ascending order. The sign of the greatest term in this function is positive. So positive means increase. So same, increase, opposite, decrease, same, increase. So we'll have like this. So a local maximum at negative 2 and local minimum at 2. So negative 2 here, then 2. So when it's increasing, it's right here when it's increasing. So when x is less than negative 2, or everything that's before negative 2 and everything that's after 2. So here is basically negative 3, here is negative 4. So then you have negative 5, and then you have here 3, 4, etc. So when x is less than negative 2, and when x is greater than 2. Okay. They give us table of variation. They want us to analyze it. So here they told us the curve has a maximum at x is equal to 3. When x is equal to 3, right here, it's a stationary point by the circle. So it increases, then it decreases. So it goes like this. This is a local maximum, so it is correct. Minimum at x is equal to negative 3. So this point, so decrease, then increase. So it's like this. So it is a local minimum. Two correct options, so these are the only two that we choose. The rest are logical except for the third one. The curve has a point of inflection at x is equal to 0. The reason we didn't choose this is because, first of all, a point of inflection is the point on the curve where the sign changes. Okay? So when it changes from positive, so when it changes from increasing to decreasing or vice versa, it's associated with y double prime. Here it's always increasing, it's always positive. This doesn't make sense. An inflection point, it needs to change. Okay, it can't just stay increasing. No, it needs to change. So it's not considered an inflection point. We said the same thing. Inflection point associated with y double prime. So it is correct. Y prime, no. Y, no. Y prime, immediately we cancel it. It's f double prime, correct. We said that it must change the sign. It must change the sign. So we choose this one. Okay, for this question, they're asking you to derive, and then you derive the function, and then you substitute by negative 1. You can do shift integral to do the derivative, and then you substitute by negative 1. But if you're using a non-integral calculator, this is how you solve it. Start deriving this function. So the derivative of 4x is 4 plus 100 multiplied by x to the power of negative 1. You take it up, okay? Put negative 1 here. So 4 minus 1, negative 1 multiplied by 100 to the multiplied by x to the power of negative 1 minus 1 will be negative 2. So over x squared. Okay, so you're left with 4 minus 100 over x squared. Substitute by negative 1. So you're left here negative 1 squared. So 1, and then 4 minus 100 will get you negative 96. Whenever they tell us, so wait, before we continue, this was the first derivative. Okay. Whenever they tell us d squared y over dx squared, it's another way of saying the second derivative, or y double prime, or f double prime of x. So basically we derive this again. So we cancel out the 4, so it will be negative 100 multiplied by x to the power of negative 2. Negative 2 here, so negative 2 times negative 100 multiplied by x to the power of negative 2 minus 1. So negative 3 over x cubed. So negative 2 times negative 100, negative, positive. So it will be 200 over x cubed substitute by -1, so -1 cubed, so -1. 200 divided by -1 will get you -200. Here we have local minimum and local maximum. They're asking us for that. So what we immediately think about is doing the first derivative. We got the first derivative to be equal to 4 minus 100 over x squared. We make it equal to 0. We can do plus 100 over x squared on both sides. So 4 is equal to 100 over x squared. Multiply by x squared, يعني cross. Wait, give me a second, it went. So I don't know what that was for, it just went. But we were, sorry, I was out for 1 minute. We were here, 4 is equal to 100 over x squared. And we cross multiply, so 4x squared is equal to 100. Divide by 4 on both sides. You will get x squared is equal to 25 and x is equal to positive -5. So we have 5 and -5. Now, to know which one is local maximum, which one is local minimum, what we do is we can either do test points or we can do same opposite same. Same opposite same is way easier, way faster. So same opposite same. The derived equation, it was 4 minus 100 over x squared. Usually what we do is we take the sign of the greatest term. You would think that the greatest term is this one because you see x squared, but you're wrong, it's in the denominator. So what we do is we multiply by, we take it to the numerator, so multiplied by x to the power of -2. And which one is the greatest term? 4 alone is basically saying 4 multiplied by x to the power of 0. What is greater, 0 or -2? Of course 0, because x to the power of 0 is 1. So of course it's 0. So 4 is actually the greatest term. So, and it's positive. So increase, decrease, then increase. It was -5 and 5. We do it in ascending order. Local maximum at -5, local minimum at 5. Okay? Now, to find these points, we substitute in the original equation. The original equation was 4x plus 100 over x squared. We do 4, 5 plus 100 over 5 squared. You will get 40, and you do the same but with negative. So, and you will get -40. For part E, let me just clear up all of this mess. Okay. They want when the function is increasing. This is what we got, right? When it's -5 and 5 right here. When it's increasing, it's basically this part. Okay, so they wanted everything that's before -5 and everything that's after 5. So, it's basically, we can do it like the first question. When x is less than -5, because here will be -6, -7, and then everything that's after 5, because here will be 6, etc. So everything that's greater than 5. Okay, so on the number line, think about the number line. It's everything that's bigger than 5 and everything that's smaller than -5. That's why the interval we chose is this. We chose this interval because everything that's before 0, okay, it's kind of, or like negative infinity, will kind of give you like it's like before -5 when it's increasing. Remember, increasing. And the same thing, union means or. Remember, if you this condition or this condition, in either condition they will be increasing. Okay, not that in both conditions must be satisfied for the curve to be increasing. No, it's either in this segment or in this segment that the curve is increasing. And then you have it after 5 will get you positive infinity, so a positive number. And in this case, we said that a is equal to 5 because we got it here. We said it based on like question number 1. If you think of question number 1, we use these conditions and we did it like so. If you still find it unclear, think about it like intervals, okay? Like in this way. They just made it a bit weird. They just used infinity. They used it like they were doing coordinates, but they're just overcomplicating it. You can think it in a simpler manner by doing this form. Okay. For this question, they want the value of b in this case with this surface area. What can you notice that's different between this surface area rule and this one? You have the radius here, you have pi here, everything is here the same except for the height. The height is not included. They gave us volume, and we know the rule of the volume of the cylinder. So what we can do is find h in terms of r and substitute it in this equation to get this one. So 3456 pi is equal to pi r squared h. Okay, divide by pi r squared to isolate h, and pi will cancel out. So you'll get 3456 over r squared is equal to h. Now substitute again in the surface area rule, so 2 times pi times r, sorry, it was r squared here, multiplied by the height, which is the same as 3456 over r squared plus 2 pi r squared. Divide by r on both sides, so the square will cancel out. 2 times 3456 will get you 6912 on the calculator. To make it neater, put pi here, and you will get this. In this case, b is equal to 6912. Now they want when the radius is minimal. Immediately, you see this? Minimal, maximum, anything, derive. So derive this equation right here, 6912 over r pi plus 2 pi r squared. Derive this 6912 pi multiplied by, take r on top, so r to the power of -1, multiply by -1 here, so negative 6912, and -1 minus 1 will get you -2, so pi multiplied by r to the power of -2, so basically over r squared, plus deriving this, take 2 here, so 2 times 2 minus 1, so 4 pi r. Okay, now you make it equal to 0 to find the roots. So do plus 6912 pi over r squared on both sides. So plus 6912 pi over r squared is equal to 4 pi r. Now multiply by r squared on both sides, or you can just cross multiply by r squared, so you get r cubed. Divide by 4 pi to isolate r cubed over 4 pi. Pi cancels out. 6912 divided by 4, you will get 1728 is equal to r cubed, and the cube root of 1728 will be 12. You only have one root, so there's no need to make sure maximum or minimum. Okay, now for this question, same thing. They want h, they give you volume, so 2000 pi is equal to the given volume pi r squared h. So divide by pi r squared on both sides to isolate h. Pi r squared, pi and pi will cancel out, and we'll get 2000 over r squared. Now that you have the height given this, find the surface area in terms of height. So the surface area is 2 of the cylinder, 2 pi r times the height, so times 2000 over r squared plus 2 pi r squared. R cancels out here, so you'll be left with 1. 2 times 2, 2000 will be 4000, so 4000 pi over r plus 2 pi r squared will get you this. Now they want ds over dr, yani the derivative of the surface area. So deriving this, it will be 4000 pi multiplied by r to the power of -1, bring it up, and -1 here, and -1 minus 1 will be -2. Deriving this, you put the 2 here, so plus 4 pi, 2 minus 1 will be 1, so plus 4 pi r, and -1 times 4000 will be -4000. Take the r squared down, so over r squared plus 4 pi r, so you got this. Now they want you to make it equal to 0, okay? So basically 4 pi r minus 4000 pi over r squared is equal to 0, plus 4000 pi, يعني add it on both sides and you will get that 4 pi r is equal to 4000 pi over r squared multiplied by r squared on both sides, or like cross multiply, and you will get r times r squared will be r cubed, divide by 4 pi on both sides, 4 pi, and pi will cancel out, and you will get r cubed is equal to uh, 1000, and cube root يعني r will be equals to 10. Okay, we said that this, when they square it, means a second derivative. Okay, so this is the first derivative, negative 4000 pi over r squared plus 4 pi r. Second derivative of this, you derive it again. So take r squared to the top, put negative 2 down, so negative 2 multiplied by negative 4000 pi multiplied by r to the power of negative 2 minus 1 will be negative 3 plus 4 pi r. So take it back down, so over r cubed plus 4 pi r, negative 2 times negative 4000 will be 8000 pi plus 4 pi r. This expression is a positive expression, so it will always be positive. Now they want the minimum surface. يعني it's nothing related to double derivative. Minimum surface area يعني the first derivative. So this one, they want r. The only r that you got is 10, so you put 10 here. So, and that's the only r, so there's only to find out minimum and maximum. That's the only r. It's minimal always, okay? It's like the minimum radius that you will get. It's not working. For this question, they want us to find the derivative, so let's derive this one. 3x squared minus 2 times 18 will be negative, it will be 36. X, 2 minus 1, plus 81. X cancels out, and negative 108 is cancelled. So we have this. Then to find the roots, we do mod 5 3, and you will get 3 9. So 3 is placed here and 9 will be placed with B. They were kind enough to give us a table of variation right here. So we have when it's 3, it's increase, then decrease, then B, which is 9, and then it will increase again. So it will be a maximum at 3 and a minimum at 9. Okay. Okay. For this question, they told us, okay, they gave us an uncompleted quadratic equation. They gave us the roots in terms of r, and they want us to find what the value of r and the value of c. We learned two relations that link quadratic equations with the roots. One of them being that negative b over a in a quadratic equation is equal to the sum of the roots, and c over a in the quadratic equation is equal to the product of the roots. Okay, so let's fill in the blanks. Negative, so what's b? 12. What's a? 1. So like negative 12 is equal to the sum of the roots. The sum of the roots will be r plus negative 4r, or r minus 4r, which is negative 3r. Divide by negative 3 on both sides, you get 4 is equal to r. So r is equal to 4 right here. Now, so this is 4, since the other root is a multiple of r multiplied by a factor of negative 4, so it's basically negative 4 times 4, which is basically negative 16. So c, which we need to find, over a, which is 1, so just c, is equal to the product of the roots. Negative 16 times 4 is negative 64. So basically, c is equal to negative 64. So here it is. these are the roots, right? In a factored form, so these are the roots. So it will be x minus 4. The positive root will be in the negative factored term, and the negative root will be in the positive factored term, since it's what makes it equal to 0, you know? So like you switch them. This is from grade 9. Okay. The coordinates of the turning point. Turning point, immediately what you do is you derive. So we derive this. Let's complete it actually. X squared plus 12x minus 64. You derive it, you get 2x plus 12 is equal to 0. This is y prime. So 2x is equal to negative 12, not positive, negative 12, and x is equal to negative 6. Now that you got x, substitute x or negative 6 in the original equation. So negative 6 squared plus 12 times negative 6 minus 64, and put it on the calculator. You will get it equal to negative 100. Okay, what is the rule for the volume? It's the area of the base multiplied by the height. So basically the volume is equal to 810. X is equal to 9, so it's a square, so it's 9. Okay, the area of the base is basically side squared, so side squared, so 9 squared is equal to 81. Now, since the volume is equal to side squared, or which is side squared, yani area of the base multiplied by height, and side squared was 81, and you know that the volume is 810, you will get that the height is equal to 10. For this question, the curve C of whose equation, okay, they gave us this equation, they want local maximum. خلاص, immediately you do f prime of x is equal to 3, take the 3 down, so 3x, 3 minus 1 is 2, 3x squared minus 6x, that's it. You can, you put it on the calculator, so, يعني mod 53, or you can do it yourself. 3x x minus 2, so you will get x is equal to 0 and x is equal to 2. Okay, now you need to know if it's local maximum or minimum. You can do s or s. The sign of the derivative of the biggest term was like, it was 3x squared, it was positive, right? So it's same, increase, down, and increase. 0, 2 in ascending order, so you will have a local maximum at 0 and a local minimum at 2. Now they want the value there at x is equal to 0. Value there, it means they want the y, the ordinate they want. So you basically substitute this by 0. So 0 cubed minus 3 times 0 squared plus 13, and you will get 13. Okay, inflection point, you derive twice, a second derivative. So the first derivative, f prime of x is equal to 12, take the 3 down, 12x squared. Okay, second derivative, again, you take it down. So f double prime of x is equal to 24x. You make it equal to 0, and you get x is equal to 0. Okay, for this question, they told us that there's a square of side x, like this, all the sides are x. Sorry, no. It's a square of sides 30 and 30, okay? In the square, okay, the mistake I did is that in the square, each corner you cut off a square of side x, okay? This is what they meant. Always make sure to read the question properly. In the square, they cut off squares of sides x and x, okay? So basically, they want the volume of the square. So what you do is, what's the rule for the volume? It's the area of the base times height. What's the base? Side squared. What's the side of here? We said it's 30, right? But the new side is 30 without these sides right here. Okay, so you have x and x. So it's not only 1x, it's 2x. So it's 30 minus 2x, and it's side squared, so all of this squared. Now they said they folded these sides right here, these sides. They folded these sides So this side right here, they folded them up. So let me use another color. They folded them up. Okay, it's hard to illustrate, it's hard to do it, but they folded them up. Okay, to make kind of like an opened box from the top. Okay, now when you fold it up, this box will have a specific height. This height will be this side. This is x. Okay, so the height is x. Okay, now basically this is an optimization question. So what you do is you need to find the conditions. To find the condition, you take what's in the brackets, so 30 minus 2x, and you make it equal to 0. Ignore the square, ignore the x, okay? Make it equal to 0, okay? You get 30 is equal to 2x, and x is equal to 15. So basically, you do this. This is the condition. You always start with 0, must be less than or equal to x, which is less than or equal to 15. This is the condition, okay? Start with 0 and then you do 15 from what you get from what's in the brackets when you make it equal to 0. So now that we're done with the condition, we have x 30 minus 2x squared. Let me use another color. So they want a maximum. Immediately what you do, you make it equal to 0. Not make it equal to 0, actually. You derive. Okay, you derive. Sorry for my mistake. You derive. Okay, so basically you use product rule. This is u, this is v. So u prime v multiplied by u v prime. So what's the derivative of x? It's 1 multiplied by, copy this, 30 minus 2x squared multiplied, sorry, not multiplied, added, not u prime v plus u v prime, okay? Plus, not times, plus u, this case keep it the same. Now v prime, how do you derive this? Using chain rule. How do you do chain rule? It's 2 steps, okay? You take the power down, so 30 minus 2x, and you make the power minus 1, so it will be 1, okay? Multiply this time by deriving what's inside. The derivative of 30 minus 2x, okay, it will be negative 2, okay? So negative 2 times 2 will be negative 4, and negative 4x, so negative 4x multiplied by 30 minus 2x, okay? Now this, what you derived, you make it equal to 0 now, okay? So basically 30 minus 2x squared minus 4x distributed to 30 like this. So sorry, just 1 second. So 30 minus 2x squared minus 120x plus 8x squared, okay, equal to 0. Now you distribute this 900 minus 30 times 2, remember a squared plus 2ab plus b squared, or now it will be minus, so 30 times 20, 60 times 2, negative 120x plus 4x squared minus 120x plus 8x squared. So minus 120x minus 120x will be minus 240x, okay, plus 4x squared plus 8x squared, you will get plus 12x squared, plus 12x squared. Okay, that's it. We didn't forget anything. So this is equal to 0. You do mode 5, mode 5-3, so 12, then negative 240, then 900, and you get 2 answers, 15 and 5. Side note, there's another way to simplify this. Actually, when I was solving the quiz, I did it the other way. but this time I stumbled upon this way. But now you get two answers, 15 and 5. They want a maximum. How do you do maximum? You do SOS. The sign of the greatest term when it's derived is positive. So increase, decrease, then increase. You put it in order. 5 is lower than 15. So maximum at 5, not 15. They want maximum, so 5 centimeters. Okay. For this question, value of the gradient of g at the point where x is equal to 0. Gradient, immediately you derive. It's another keyword. You derive. How do you derive this? Chain rule. Put the 4 down. So 4 x squared minus 2x minus 15. 4 minus 1 will be 3 multiplied by deriving what's inside. 2x minus 2. Distribute the 4. You get 8x minus 8. Okay. And then x squared minus 2x minus 15 cubed. Now you start substituting x by 0. So 8, 0 minus 8. You do this on the calculator. 0 squared minus 2 times 0 minus 15 cubed, and you will get 27,000. Okay? Now, how many stationary points does this have? This term right here has 1. Okay, it's linear. And this term right here, now, you see the number 3? Okay, you will say it's 3, so it has 4. You're wrong. Ignore the exponent here. Only look at the inside. It's a quadratic expression, so it will have 2 stationary points. So 1 plus 2, you will have 3 stationary points. Now, if we look here, let's look at this. They told us local minimum or local maximum. We have 3 stationary points. So we have 1, 2, and 3. Now, they told us local minimum or maximum. Yani there's no place for there to be a saddle point. It's only minimum or maximum, either or. There is no third option. It's this or this. So, what can we do? First of all, let's find, since already derived, let's make it equal to 0. So 8x minus 8 is equal to 0. So it will be 8x is equal to 8. X is equal to 1. So you have 1 right here. And if you do modify 3 of x squared minus 2x minus 15, again, ignore the cubed. So 1, negative 2, negative 15, multiply 3, and you will get 5 and negative 3. Now, let's put it in ascending order. Negative 3, 1, 5. Now, what you would do is OS, but it's not really that accurate. So usually, like, the best way that you can do is test points. It's the most accurate way. So what you do is you find a number. So these are the stationary points. So you find the number before negative 3, so negative 4. Number between this is 0. Number between 1 and 5 is 3, and after 5 is 6. So you can do test points. What you do is you substitute negative 4 in the derived equation. 8x minus 8, x squared minus 2x minus 15, all of it cubed. So you do 8, negative 2, negative 4, we said, minus 8, and then negative 4 squared minus 2 times negative 4 minus 15 cubed. Okay, and you will get, wait 1 second, 8 negative 4 minus 8 negative 4 squared minus 2 times negative 4 minus 15, all of it cubed, and you will get negative 5864. So you will get a negative number, so it will decrease here. Okay, so what we are supposed to do is then substitute this one, then substitute this one, then substitute this one. But to make it easier for you, actually you will get a saddle point. But they wanted local minimum and local maximum strictly local minimum and maximum. There is no space for saddle. They told you minimum or maximum. End of the story. So if this will be decrease, then obviously this will be increase, then followed by a decrease, then followed by an increase for there to be no saddle points. Okay, so you basically do the opposite one after the other. So you will have a minimum at -3, a maximum at 1, and then a minimum at 5. Okay, for this question, minimum maximum immediately derive, so y prime will be equal to 6x squared plus 12x minus 48. Then you make it equal to 0 and you will get 2 and -4 by doing mod 5-3. Now you can do two ways to know whether you need to put it here. Either by doing SOS, by doing it with the local minimum or maximum property, or by substituting either point in the original equation to know which one is with -55 and which one is with 161. Let's do SOS for the sake of time. It will be positive here, so increase, decrease, increase. So it will be -4 first, then 2. So it will be local maximum at -4 and local minimum at 2. Or you can just substitute either point in the original equation and then group them with the respective point, as I said. Now, here, concave up, concave down. What you do is you do second derivative. So y double prime will be equal to, we said that y prime was equal to 6x squared plus 12x minus 48. So y double prime will be equal to 12x plus 12, make it equal to 0. So 12x is equal to -12, x is equal to -1. Okay, so -1, -1. You can do the second derivative by memorizing a specific property, but if you get lost, okay, what you can do is it's concave up like this, okay, and here is -1. It's concave up when x is greater than -1, because here will be 0, here will be 1, here will be 2, right here will be 3. So when it's greater than -1, and concave down when the values of x are less than -1. For example, -2, -3, etc. For this question, they want us to know which graph it is. So we have 4 graphs. And okay, basically, by looking above these circles are the stationary points, okay? So how many stationary points do we have? We have 3, okay? So first of all, they give us an information when f of x is equal to 0, or when y is equal to 0, since y is equal to f of x is equal to these points. When it's equal to 0, we will get certain values of x. We call those x-intercepts because they intercept or they intersect the x-axis at these following points. But this information is so useless since all of these 4 graphs actually intersect the x-axis at these points. So we're just gonna have to rely on the table of variation right here. Let's look at -3. When it's -3, there will be a decrease and an increase. So it's a local minimum at -3. So let's look at the graphs. At -3 right here, it's a local maximum, not a minimum. So we eliminate this one. At -3, it's gonna be a local minimum, which we're searching for, so it's correct so far. At -3, it's a local minimum, so it's correct so far. And -3 here maximum, so we eliminate it. So we have 2 so far that are correct. Let's look at 3. It will also be a local minimum. So a decrease, then an increase, like this. Okay, so we were left with these 2 graphs. At 3, we have a local minimum here, so it's correct. And at 3, we have a local maximum, which is wrong. So we choose this graph. We can actually, to make sure our work is correct, we can analyze it even further by looking at if it's concave up or down. So here it will be concave up, then down, then up. So it's up, which is correct. It's up, then down, which is correct, then up, which is also correct. And then we can analyze 0 to also make sure if it's correct, which it is. So this is the end of the video, and good luck.